Be here with you. I'm Melanie Lang. I'm the track lead here for you today. I'll be introducing the presentations and keeping us moving along. And I also have Liza Allison here. She's our digital ambassador. So she'll be also working behind the scenes. If you're a presenter, she'll check in with you and make sure that you're ready to go on stage, and also just be helping kind of move everything along. So if you have any questions, feel free to send either of us a chat and we'll do what we can to help you. There are some directions posted in the general chat in terms of how to use this platform and how to update your profile. So please take a look at that as well if you need any help with that. Liza, would you like to say anything before we get started?
You know what? I just wanted to welcome everybody and thank you all for attending. I think this is going to be a really exciting event, and I'm super excited for this first presentation with Hot or Not about the AM industry trends. I'm excited to see what this is all about.
It'll be an awesome presentation, I'm pretty sure, especially based on who we have kicking us off here. So I'm going to bring Laura and Stephanie on stage here. I want to introduce these speakers first. They are kicking off our entire industry track for this conference, and I couldn't think of two better people to do it as experts in the AM field, and they have just an awesome understanding, across the industry of what's going on. So we thought we'd have a little fun with it. Laura Eli is the Director of Programs at the Barnes Global Advisors, an independent engineering firm with over 150 years of AM experience. She helps customers on their AM journey, operating at the intersection of strategy, technology, and people. She spent the first decade of her career optimizing materials and processes, ranging from rolling and annealing to friction stir welding and spin forming. Her heart sits with directed energy deposition. Woohoo! Force behind an $18 million CRADA with Oak Ridge and the creation of a new technology team for GKN's North American division. She mentors young engineers and passionately supports 3D printing and STEAM activities at her children's grade schools. Thank you so much for being with us, Laura. And we also have the amazing Stephanie Hendrixson. Stephanie is Senior Editor of Additive Manufacturing Media, a B2B publication where she covers new 3D printing technology and how additive manufacturing is changing production. Lately, she's been interested in stories involving unusual materials, non-manufacturers becoming additive manufacturers, and the pursuit of sustainability through AM. Stephanie is also co-host of the award-winning video series, The Cool Parts Show, as well as the recently launched AM radio podcast. Without further ado, let's welcome Laura and Stephanie. Take it away, ladies.
Thank you for the warm welcome, and thank you for the opportunity to be here. For starters, I started looking through the list of industry track and what's been put together, and I started getting really excited to be able to hear about these things. AM carries the promise of limitless designs with efficient and new material usage and rapid innovation. But juxtaposed with that is the use of AM in industrial setting. And in that case, we want it to be normal. We want it to be used regularly. We want it to possibly even be boring. And so we're going to kind of talk about that with our Hot or Not sequence. But this industry track is filled with all different topics, from fashion to transportation to health and recycling, what you can do with green lasers, and space and defense. So we're excited for you to join us as we discuss some of these industry segments, as well as some of the key trends in AM. But first, perhaps Stephanie can tell us how we plan to play Hot or Not.
Yes, so there are lots of different topics, different trends, different industries that are going to be covered here in the industry track. Laura and I have picked out 16 of them, and we're going to run through and rate each one hot or not. But just to quickly explain the scale here, if we rate something hot, that means that there's a lot of activity, it's growing, it's expanding, it's developing, we're still answering questions, we're still learning about that thing, and we're probably talking and hearing about it quite a bit. If we rank something as not hot, that's not necessarily a bad thing. That means it's reached that point of normalcy. It's matured. It's boring. It's happening, and we know that it's happening, but we may not be talking about it so much. There's not as much buzz around it anymore. And then we also have the option to rate something warm. This might be a previous hot topic that's cooling down. It might be something new that's coming in that's starting to heat up. So there is sort of a middle ground here as well. So for each of these 16 applications, markets, trends that we're going to talk about, we are going to kind of quickly summarize, give you maybe a couple of examples of what it is that we're talking about, talk about the drivers, why 3D printing is being used in that space, and then we're going to give our ratings. And I think Laura and I are going to agree on most of these, but we may disagree a little bit. We may have to talk about that. And we also want to encourage audience participation. So it's not just about my opinion or Laura's opinion. We also want to hear from the audience. So if you have if you want to weigh in on whether these are hot or not topics, please type it into the chat, and let's get some conversation going on the side here.
Excellent. You guys ready?
All right, so we will kick things off with tool and die. So what we're talking about here is 3D printing being used to make things like cores and cavities for injection molds, sand molds for casting, basically situations where 3D printing is building something that's going to form or shape some other type of material. So we've seen direct metal laser sintering being used to make molds with conformal cooling. Sand binder jetting has been used pretty frequently. I have mantle up there. That's sort of a newer technology, the true shape process where you're printing with a metal paste and then you sinter it, and they can pull things out of the sintering oven that can go directly into an injection molding situation. And so we see 3D printing being used for tool and die applications because of the geometric complexity that it enables, because of the assembly consolidation, makes it a little bit easier to build these complex geometries, and the opportunity to introduce conformal cooling and other potential like performance benefits in use. So I think we're ready to rate this one. What do you think?
I'm going not. I love that new areas are always expanding, but I think people have kind of figured out that tool and die AM, they've figured out, the schedule savings, the opportunities, and the good, sweet spots. But I absolutely love to see more development in this space with the expanded materials and new applications. So it's still a great space, but I think people are kind of done with talking about it because they kind of understand it.
Yeah, absolutely agree. I think it's become very well known that there are benefits to 3D printing tooling.
Absolutely. All right, moving on. Rapid fire. Space. Okay, so when we're talking about space, we're talking about launch vehicles. We're talking about maximizing a payload that gets taken up, and performance improvements. So some of the pictures that we have here are NASA, the Perseverance Mars rover has multiple 3D printed parts on it that are additively manufactured parts that are roving around on Mars right now. I think that's a word, roving. The bottom left hand is an example from Launcher. They're a small sat launching group. They have been using 3D printed parts. There's an orbiter propellant tank that's shown there. They've also done a shrouded impeller for their rocket engine turbo pump, working closely with Velo with their capabilities. And the last one that I put on there, the video that just played, was DM3D worked with NASA Marshall Space Flight Center and made this 10-foot tall, of course, I had to put a DED example in there. Later on, just of note, is NASA and JPL will both have presentations later in the industry track. So if you're interested in learning more about this space, we will definitely have that on the agenda. So I rate hot.
Definitely
hot. Yes. Okay, so everyone's in agreement there. I think it's really exciting to see the developments, and I think we're just going to continue to see more and more as people are kind of figuring out the mission assurance requirements. Okay, next category, aerospace, obviously not including space. I think when we look at this on the left-hand side of the screen, I put up pictures that everyone, if you've been in the aerospace space, you will have seen before. Ducting, we have the Norse titanium floor grid ducts, brackets. We have the Airbus little bracket. We have things like the GE Leap fuel nozzle, all of those things. And those have been around for quite a while from an application standpoint. I will kind of highlight two areas, though, that Stephanie and I were talking about that are interesting and they're starting to move that would be in the general aerospace, and that's urban air mobility. So this is showing a Joby Aviation electric vertical takeoff and lift vehicle. They have made a comment that they will be using titanium structural AM components on this vehicle. And then also unmanned air vehicles and drones. Which again, sometimes those qualification and the safety requirements aren't quite as high, and you have this iteration and rapid design process that we're able to do there. So what does everybody think? Okay, we've got at least one not hot in there. Aerospace warm. Fair enough. I'm going to say not on this one. And I think we are going to continue to see progress. It's just kind of more of the tortoise pace of progress.
Yeah, and I think like here it's a little bit similar to tool and die. Like there are some really well established technologies and use cases, and so but the benefits that 3D printing is bringing to things like drones and urban air mobility are very similar to the benefits that it's already bringing to other types of aerospace. So it's just sort of like getting into a new product or a new market that's kind of all within the same sort of family there.
Yeah, agreed. I will note that we do have a panel later on in the industry track that's AM in the U.S. Army and Aerospace. So that should hit more of this topic a little bit later.
All right, so we have fashion and consumer goods. And if you were in the keynote this morning, you already heard some really, really cool cutting edge fashion stories. But what we're talking about here is more direct to consumer products that are being 3D printed, mostly things that you can buy, you can purchase today. And so there are a lot of reasons that 3D printing is being used in the consumer goods area. And some of it is because of the way that you can size things precisely to fit a unique individual, the way that you can customize things. So that's the case for like the Atrex insoles there, the Fitz Frames glasses, which I'm also wearing. You might also want customization that's enabled through 3D printing because of your personal taste or style. So like that's the case for the future of jewelry rings, which Casey Melvin is going to be speaking in the industry track, I think later today. And then there are other reasons as well where we see people using 3D printing as a way to get to a more sustainable product. So that's the case for Hylos. Those shoes are consolidated into just a couple of materials. They're much easier to recycle. They're also being printed on demand. Again, Gaia Galati from Hylos is also presenting in the industry track. And then there are functional reasons to use 3D printing as well. So like the Cobra Golf Club is an example where they chose this design as a way of reducing the twist in the club, so improving its performance, and also for the reshoring aspect, moving to metal 3D printing for this club head allowed them to bring the production closer to home, closer to where people are going to be buying it, closer to where it's going to be finally assembled. And so there are a lot of different ways that we see 3D printing being used in this space. And then, as Melanie said at the top of the presentation, I'm really interested in cases where people who were not previously working in manufacturing become manufacturers just because they had a great idea. And that's the case for a couple of the products on here as well. So 3D printing is a lower barrier to entry than something like injection molding. And so it turns out that a lot of designers and people who maybe aren't necessarily working in manufacturing right now come to 3D printing as a way to make this thing that they'd like to sell. So all that being said, I'm going to rate it hot.
I'm going to go hot as well. I think you're starting to get to more of the mass impact. I think it's still kind of in certain pockets. So it's not necessarily, I don't think it's reached its end destination yet, but I certainly put it on the warming up curve.
Yeah, absolutely. And I think a lot of, not necessarily the things on this slide, but there are some other products that are pretty expensive right now that are being 3D printed. And so I could see the cost coming down. And then some of these things like the insoles depend on a very specific type of scanner, like you need a pressure map of your foot. And so some of that scanning technology is not yet readily available. And yeah, so it has not reached its final destination. I agree.
Absolutely. Okay, our next topic is transportation. And I've done this broadly, so automotive and rail, all included within this. The example on the bottom left is the Zinger hypercar. Kevin it's Kevin Zinger, has Divergent 3D as well. And so they are doing toolless 3D printing of lightweight structures. And this is another one of those where you're seeing additive as a part of advanced manufacturing. They've got robotics involved. And this was also one of the drivers for the SLM Next Gen 12 laser machine, because they are wanting to get to the production volumes that are required for automotive industry. The other thing that we have going on in automotive is, of course, this move to electrification. So similar to our electric VTOL example, weight savings are a huge driver. You've got to offset, battery weight. And of course, being able to optimize for things like crash impact and other things are a big deal. On the rail side of things, there's actually quite a bit going on in that space as well. So we've got an example from Wabtec. They have a facility located at Neighborhood 91 next to Pittsburgh Airport. They're doing aluminum 3D printing for a variety of parts. And the other one that I put on here is Deutsche Bahn. So Stephanie Brickvidi will be presenting later on. She works with Deutsche Bahn, multiple parts there, one of which is braille on a handrail. So that one was pretty neat because, of course, you're introducing new functionality. And then she also was the starter for Mobility Goes Additive. And she also runs a Women in AM event in conjunction with AM Forum in Berlin. So I think this is an interesting space. There's kind of different requirements. Let's see. People are pretty much saying hot. Yeah. She's warm. Yeah. I'm in between. But since I'm binary here, so I can only go hot or cold. So what do you think?
I think similar to what we said for consumer, like it has not reached its final destination. I think there's a lot of question, like how far, at least in the automotive space, like how far in terms of quantity can 3D printing do? Is it ever going to get to the level of like an F-150? But there are definitely great applications out there. It is definitely warm to hot. I will concede that.
Fair enough.
All right, so dental. We are talking here about things like 3D printed models, mouth guards, 3D printed tooling to make aligners, dentures, all these sorts of things. You can see I have actually had direct experience with this. We did an episode of the Cool Parts Show where we visited Spectrum Dental, which is a dental lab in Columbus. I went through this entire workflow where I got my mouth scanned. They printed a mouth guard for me. And this is something that as the dental industry kind of gets more digitized, as more dentists start to use these 3D scanners, it's a pretty natural workflow to move from the 3D scan to the 3D printed device. And so this is something that I guess if I say any more about it, I will probably give away what my vote is. So let's go ahead and write it.
All right.
Not. So this is the episode that I'm talking about that we did was about 2 years ago, and at the time it only took about 2 hours from the scan to me actually putting this mouth guard in my mouth. So the process was already pretty mature at the time, and now there are even more printers and materials and sort of options for this. So it feels pretty mature to me, but I think maybe it's not as widespread as we'd like it to be, just because dentists don't necessarily have the scanning technology. They're not necessarily digitizing as fast as we might like them to.
Yeah, I agree. While I said not because I think it's found its place in a productive environment and people have figured it out. My daughter had her orthodontics recently, and I was pretty disappointed to see the plaster tray and the old school way. So it's not completely. Maybe we are a little behind here in the Midwest. Okay, our next category is medical, which is, of course, a broad category. So when we're talking about this, we're talking about the ability to customize designs. We're talking about improved patient outcomes. We're talking about optimizing performance. So some of the examples we have here are some implants. A nice picture from Tangible Solutions, who does 3D printed titanium implants for both spine and joint. They're leveraging end topology optimization design work. We also see an incredible amount in the prosthetics. And going back to Anouk's, I mean, the combination of prosthetics and fashion is like this incredible next level of amazing and cool. But I think with those, again, the customizable bit is the big deal, and kind of the local on demand, able to, print and give people, these customized prosthetics same day or next day. The final one is an example. It's actually resorbable printed bone. So we talk about osteointegration for implants. This one, actually, the bone takes over it and it resorbs, and then there's bone in its place, which kind of just blew my mind. So I think so much exciting going on here. We have multiple talks we have one on pre-op and healthcare, AM in hospitals, bioprinting and biofabrication. So I really recommend you look and see where those are falling in the industry track. So I'm rating hot.
I'm going to dissent just a little bit. I think that standard implants, not so hot, like especially Tangible Solutions, like these guys have figured out how to do standard implants. It's really impressive. But I would say hot for custom implants, for prosthetics, orthotics, definitely, and bioprinting, just red flaming hot right now.
Gotcha. All right, we're rapid fire through here.
All right, we got to speed up here. All right, so construction. So we're talking in situ concrete 3D printing, like the Icon printer that you see there. We're talking prefabricated 3D printed structures, like what Mighty Buildings is doing. Possibly also things like architectural elements, like bridges, maybe 3D printed tooling for concrete. Construction is a space where 3D printing brings a lot of benefits in terms of sustainability. Like you can use less material if you're only putting down the concrete that you need. You're only building the wall that you need. You're not trimming a lot of lumber and like creating a lot of waste that way. Construction is another area similar to manufacturing where there is a skills shortage, a labor shortage. And so 3D printing allows for some automation, allows you to do less with the crew and the people that you have, potentially leads to safer work environments. And so, yeah, I think let's rate it.
I'm going hot. I totally agree.
Also, yeah.
I'm excited. Next time I go to Austin, I'm hoping that I get to see some buildings being printed. It would be awesome. Okay, so our next category is energy. So one of the examples we have is S.J. Jones from Siemens Energy. So she is holding a part where 3 parts were consolidated into one print for a gas combustion system. I think this space we see also, the prototyping ability and analysis. So a small scale hydropower test bed was done by Cadence, which is interesting as well. So you're looking at, optimizing and then taking that up. The other area, and I was just down at Oak Ridge this last week, which was exciting, is what's going on in nuclear as well. So they have a program called the Transformational Challenge Reactor, and this is where you can use new access to materials and speed that weren't there before, embedded sensors, all kinds of exciting things. And then the other area is oil and gas has multiple groups that are playing in finding their space. I think it's another one that's just going to continue emerging as far as those winning applications. We do have a couple of presentations. One is on how AM is disrupting the energy industry. And so, tune into that one. But I think we need to rate this one. Yeah, I really want warm on this one. Am I allowed to? I'll just twist.
Yeah, that counts. That counts. Yeah, definitely warming up for sure.
Gotcha.
All right, so sustainability. There are a lot of different ways that additive and sustainability can sort of go together. We've focused here on materials. There are biodegradable material options. There are recycled material options, like what GreenGate 3D is doing with PETG, like what 6K is doing with metals. Beyond the materials, there are additive also offers opportunities like assembly consolidation. You can use fewer materials, use fewer fasteners. You can make these really lightweight, optimized geometries, maybe make products that perform better, that are more durable. And so there are a lot of different potential ways that 3D printing and sustainability can work together. So to rate this, hot to warm, yeah.
Hot to warm, yeah.
Or warm to hot.
I agree. I think they're figuring it out, and I think AM is a really good complement to that. So I think there's lots and lots of opportunities. And there is a recycling presentation on day 2, which is recycling of materials for AM processes as well. So
yeah, And I guess the big gap that I see here is that we're not there aren't enough like life cycle analysis type things out there yet where you're absolutely sure that this 3D printed bracket is better than this standard machine bracket. Like we need studies, we need people looking at this. That's something that the AMGTA is studying, the Additive Manufacturing Green Trade Association, and I believe they're doing a presentation maybe tomorrow. So keep an eye out for that to learn more about this.
That's a good segue into our next topic, which is just advanced materials in general. I think it's really important to remember it's that material and process balance and what that creates. So whether we're talking about ceramic, this is a ceramic implant from Lithos. Fortify is really cool. They have polymer, and they have metallic particles within there, and they are using a magnet to align those particles for specific performance. It's kind of amazing. We have carbon nanotubes with Mech Nano. We have continuous fiber printing with an isoprint and a whole bunch of others. So I think in this space, it's like, this is majorly hot. Okay, so I'm just gonna.
Yeah,
it's not just because I'm a materials engineer. I swear.
The chat is just scrolling by with hot.
Yeah,
So
we've just blown this space up. Okay, so we have agreements across the board.
All right, so next topic, all sizes welcome. And so what we're talking about here is additive manufacturing, like going to the extremes and everywhere in between. So we have the capability to do really, really tiny prints like what NanoFabrica is doing. This is an alternative to things like micro machining and micro molding, where 3D printing can be used to make the end product. It could also be used to make the mold. It can also be used for prototyping so that you can figure out the right design before you go through all of that to make a really tiny mold. And then on the other end of the spectrum, we have so many more options now for large scale, large format 3D printing, things like the big area additive manufacturing machine, the BAM, which was used to make this flight simulator body that you see from Additive Engineering Solutions. This is a case where 3D printing provided assembly consolidation benefits. This was part of a project with L3 Harris where they were trying to reduce the number of parts that the simulator needed from like 3,000 down to under 300. And they were able to achieve that by 3D printing, in part by 3D printing this body in just a couple of big pieces. And so there are really, really small options, really, really large options. And then another thing that I've noticed recently is sort of like more medium-sized printers where you have desktop printer companies scaling up to build bigger printers, and then companies like Cincinnati Inc. scaling down a little bit to do things like the medium area additive manufacturing machine, the MAM. So yeah, very hot.
Yeah, I think there's a lot of different ones, and I'm excited by all the processes that are coming out and what that enables from a from an application standpoint. All right, we're moving fast now. Okay, so investing in AM is hot. It's burning hot. From a TBGA standpoint, we participated, I think, in 8 technical due diligence as a part of mergers and acquisitions activities just last year. So what's interesting here is it's across the entire value chain. We're seeing, a consolidation of digital partners. So sometimes that's additive and subtractive, software capabilities. We're seeing trying to, enable the digital flow. The other thing that we're seeing is a consolidation amongst contract manufacturers. So you got folks like Adman and Beehive that are buying up basically manufacturing capability and combining those together. And of course, we see continued investment in the material and process space as well. So I certainly rate this one hot.
Definitely. All right, supply chain. We're almost to the end here. Supply chain is something that got thrown into the spotlight as a result of the pandemic, as a result of all these other disruptions. We in additive manufacturing have known for a long time that it can be the solution for distributed manufacturing, for expeditionary manufacturing, for building things, making things near the places that they're going to be used. And I think that a lot of OEMs and other companies who had not previously been interested in 3D printing started to see it as a solution as a result of things like the 3D printed swabs that were being made all over the place. Yeah, I would go ahead and just rate this one hot. I think this is something we're going to continue to hear about for at least a few more years here.
I absolutely agree. And we're going to go on to our last two categories here. So people and skills, I do want to mention how great additive manufacturing is for getting children and people that are, in the K through 12 range excited in manufacturing in general. So I think it's a great recruitment tool to a manufacturing. And within the DoD, there is activities going on to support the development of the workforce. And I'm kind of skipping over categories, but I'm going straight to the last one here. So designing with AM, I feel like this is a perpetual hot topic. I think it probably will remain a hot topic. And I think the other bit is acceptance of AM as a part of the advanced manufacturing family. But when we're talking about complexity, fluid flow, lightweighting, part reduction, cost customization, all of these things, so excited. The one that I wanted to highlight here, I don't know if people have seen this. I found this. It was called, it's a art installation called Digital Grotesque. And it's a full-scale 3D printed grotto. So it's like 7 tons of sandstone structure that's been 3D printed. But what they did was they did computer design that was trained to elicit human response. So you want to talk about like the intersection of software and hardware. This is just like mind-blowingly interesting to be that. So official last rating for us is hot on this one.
We made it.
We made it.
All right. So we rated most of these, a lot of these hot. And that is because additive is still very much finding its way. We're still finding the right ways to use it. I do want to reiterate here at the end that if we said it was not hot, that's not a bad thing. That just means it's matured, it's established, it's getting to the point of being normal and boring the way that we talked about at the beginning. So I want to thank everybody for joining us here at the kickoff of the industry track. If you want to reach out to me or Laura, our contact information is up here, and be sure to stick around, check out all of these great presentations in the industry track. We covered a lot really fast in this presentation, but there are so many opportunities to learn throughout the TIPE conference.
Absolutely. And I'll just say TBGA has sponsored some AM certificates. We're going to do those scholarship awards on Thursday, and feel free to visit us at table 3.07 on floor 3. Thank you.
Thanks.
Industry track, and anyone looking for keynote industry speakers,
I think these two have proven that they are pretty amazing. So thank you so much.
Thank you, Melanie.
Thanks, Melanie.
We want to get right into our next set of presentations, which is a joint presentation between Cindy Ashforth and Kirstie Snodderly. So I'm going to go ahead and bring these two ladies on stage. And ladies, if you'd like to go ahead and join and turn your camera on. And I will go ahead and start with the introduction. So I would like to introduce Cindy Ashforth first. She has over 25 years experience testing and certifying composite structures. And she is one of the FAA's subject matter experts for advanced materials and manufacturing. And then we also have Kirstie Snodderly joining us. She is an additive manufacturing R&D project engineer for ASTM International. And she has over 5 years experience, primarily in medical application and regulatory considerations. I'm going to hand it over to you ladies.
Awesome. So let's make sure you can see my screen. Yes, awesome. And everyone can hear me, correct?
And we can hear you.
Okay, awesome. Thank you. Well, thank you for that very kind introduction. As she said, my name is Kirstie Snodderly, and together with Cindy Ashforth, we are going to be discussing organizations and standards perspectives from the FAA and ASTM. Thank you for joining me today, and thank you to Women in 3D Printing and the TIPE Conference for hosting this fantastic event. I'll first start by saying, by giving a brief overview of what we'll be discussing today. I will give an introduction about myself, about ASTM, and then we'll talk about the standards role in industry, and I'll review what the ASTM Additive Manufacturing Center of Excellence is and the promotion of standards development through research initiatives. and then discuss how you can get involved in this community. To start out, my name is Kirstie Snodderly. I am an additive manufacturing R&D project engineer with ASTM International. I have 5 years of experience in additive manufacturing for medical applications. My former position was the additive manufacturing engineer for the Additive Manufacturing Medical Products Laboratory at the U.S. Food and Drug Administration. I have a Master's of Engineering and a Bachelor's of Science in Bioengineering from the University of Maryland. So a little bit about ASTM. ASTM was founded in 1898. That's right, 1898. And we are a standards development organization. The headquarters is located in Pennsylvania, just outside of Philadelphia. And I work out of the DC office, but we have staff all over the United States and all over the world. Currently, ASTM has over 13,000 published standards that apply to almost everything you come in contact with, including areas of construction, aerospace, and additive manufacturing. There are a lot of numbers on this slide, but what I find the most important on this page is that there are over 34,000 members in more than 150 countries, spanning across more than 90 industries. ASTM also provides training courses and trains more than 2,000 individuals each year. So why is this so important? This is important because it shows that standards development is not a one person or one industry task. It takes a team of experts from many different areas and across many different nations with people who have diverse backgrounds that come together and develop a consensus-based standard that allows for improvement within each industry. As ASTM operates internationally, it is no surprise that we have a Diversity Inclusion Council aimed to ensure an inclusive workplace and incorporate a diverse background of our ASTM staff and members worldwide. I think it's really important to share this information today, especially with this group, as each day we strive to further our progress and promote diversity and inclusion throughout our staff, our members, and the world. On behalf of ASTM International, I want to reiterate that we are proud to be a part of the TIPE event. Please join our ASTM President, Kathy Morgan, at 3 p.m. Eastern Time, 12 p.m. Pacific, for further ASTM DEI remarks. So, how is ASTM involved in AM? Well, in 2009, F42, the oldest and largest committee on AM, was founded. Later in 2011, ISO established TC 261 to focus on AM, and the two organizations joined forces since then to eliminate duplication of efforts globally. There are currently over 1,000 members with more than 30% outside of the US, representing more than 35 countries. This committee is broken into subcommittees with more specified focuses, such as aerospace, medical devices, maritime, and oil and gas. And these subcommittees are responsible for the initiation of standards within their specific niches. Currently, F42 has standards for general terminology, specific applications, feedstock materials, process and equipment, and for finished parts. So why are standards so important? Well, standards impact your success in 3 ways. The first is cost savings. You rely on publicly proven standards to save money and therefore increase effectiveness. The second is that shared resources. Standards come together by an industry consensus, and you benefit from sharing resources from many different entities and organizations. And the third way is that it eliminates overhead. By using a trusted process and methodology, you prevent recreating the wheel and unnecessary spending and errors. More specifically, standards development in the AM space allows us to further our goals by enabling the industry to commercialize technology, ensuring trust within the community, and establishing wider AM acceptance by industries. Overall, these standards contribute to the success and growth and acceleration of AM technologies. So the standards development process is a volunteer-run, multi-step, consensus-based approach that begins with the standards need. From there, a small group of people meet to initiate a draft, and then more and more experts are brought in to provide feedback and opinions on that. After a final review and a consensus within the main committee, such as F42, the standard is approved, published, and ready for use within the community. So, how does the Additive Manufacturing Center of Excellence at ASTM fit into this? So first, what are we? We were formed in 2018. The AMCOE is a collaborative partnership between ASTM International and organizations from industry, government, and academia that conduct research, that can conduct strategic research to advance standards across all aspects of AM technology. The center aims to accelerate the development and adoption of these technologies by supporting standardization, developing training and certification programs, and providing market intelligence and advisory services. The main objectives of the COE are to coordinate and conduct these R&D efforts that support AM standards development and support education and training of the AM workforce. So how does this fit into the standards development community, and how does this correlate to technical committees such as F42? The AMCOE is leveraged as a platform to conduct research and fill gaps in the standardization efforts. The goal is to identify the standards needs early and provide support for the research efforts to drive initiation of standards and promote the adoption of AM in the industry. So typically, standards development process can be slow as it's a volunteer process with limited data available to the standards community. There is also a lot of back and forth between technical experts throughout this entire process. By providing this front-end support, the AMCOE is promoting the standards development process by decreasing the amount of time that it takes to go from the standards need to the approval. Additionally, all COE-funded projects are reviewed by ASTM members and rely on inputs from existing roadmaps, such as the AMSC roadmaps. These projects are then selected by F42 members to address the standardization gaps. As of October of 2021, the ASTM AMCOE has contributed to 30 projects with 30 standards either created or impacted. This slide shows some of the key metrics obtained from these projects, including the standards gaps that they've addressed and the work items development, which each work item is in a different, you can see is in a different stage of the development process. But one of the key metrics that I think is important to point out here is that the standardization efforts are being conducted by 17 organizations and 22 technical contacts. These technical contacts represent a diverse group of people and experts, including women, that demonstrate that not only do these projects aim to close these standardization gaps, but they also allow for the training of the next generation of standards developers. Most recently, the COE is supporting 3 projects through our request for idea mechanism and 2 projects through our call for projects mechanism. These projects are 6 to 9 month projects with the goal to generate data that can be used as a basis for standards development process. Additional information about all of these projects can be found on the AMCOE website, which I've linked at the bottom. As there are many gaps in this industry, no one organization can lead them all. Therefore, collaboration is essential. A few examples of the AMCOE collaborative efforts include the 3 projects that we currently have ongoing with America Makes and the cooperative agreement that we have with NASA. These external projects are also driven by the standards needs and contribute to standards development initiatives by encouraging increased collaboration. So how can you get involved? As I mentioned, standards development as a whole and the AMCOE are very collaborative, which means we need your help. In order to get involved in these processes, you can get in touch with the AMCOE through and sign up to our newsletters. You can be involved in future calls for R&D projects, including the RFI and CFP mechanisms that I discussed previously. You can participate in work items that the COE is contributing to or initiating, which we have further information about on our website. Upcoming ASTM COE events are also very useful and and we have them promoted on our LinkedIn and our website. And you can join F42 and impact the standards development process. But we are not just set for these specific ways for you to get involved. If you have additional ideas about how to be involved, please feel free to reach out to us and we would love to have a conversation. The final way you can be involved is to join our team. We currently have 5 open positions that we're hiring for. So you can check out our LinkedIn to view these job descriptions or connect with us at any time during the TIPE conference and career fair. We are located on our ASTM sponsor table is located on level 4. During the network sessions, we'd love to talk and meet with you. I've included my contact information here and other resources on this slide for, take a screenshot and feel free to contact us at any time. But in the meantime, I will turn it over to Cindy, who's going to discuss how industry standards are used during FAA certification of AM parts.
Thank you, Kirstie. Let me see if I can share correctly. Can you see the slide?
Not yet.
Okay. It tells me it's sharing. Let me try again. All right, can you see it now?
Yes.
Okay, so I'm going to continue on what Kirstie was saying about how to develop standards and say, what do we do with them? And I'll begin a little bit just talking about why it's so important in the world of additive manufacturing to expect to use and rely on standards. So, there are some AM specific attributes that make it unique from traditional materials, at least when we're looking at it from a, yes.
Cindy, just so you know, you're sharing your just the actual slide deck, so you're not advancing your presentation screen.
Okay, it told me it was sharing the screen. Let me try one other way. Well, all right, I can't put it in presenter view apparently. So let me try to enlarge version and see if that'll work. Some AM, so this was, sorry, the AM specific attributes. There are plenty of things that make AM a little bit unique to traditional materials, but what you will learn is that our regulations don't change. It's just the way that you meet the regulations that is different because you're using additive manufacturing. And this isn't the first rodeo for the FAA. And other regulatory agencies either. There are many elements of additive manufacturing that are common with other advanced manufacturing methods, such as composites. And this is where our regulations don't really address these items, but yet we realize that the applicant does have to figure out how to deal with them. And that's where the subject of standards, industry standards, becomes so important. So as an example, we have a regulation for material strength properties and design values. And it says that it must be based on enough tests of material meeting an approved specification. An approved specification, well, I think we all realize you need a material spec and you need a process spec, but what actual information belongs in there? What makes it, what makes it approved is that it becomes part of your design. But when it comes to the details of what needs to be in there, and that runs the gamut. Some companies think they can get away with just listing a material, brand name or a Ultim 9085 or something like that, and without giving more details. And that just isn't going to work in the aviation industry. So this is where, an approved specification, ASTM has specifications, SAE has specifications, I'm sure other organizations may as well, that, that really help. Either if you want to create your own standard, you can, but at least they give you the type of information that we would be looking for. Now, the FAA does not approve industry specifications. There's no way to get pre-approved in that manner. All we can do is approve it each project. But if you use an industry standard specification, you can feel pretty confident that you're going to have the information that we're looking for. Another example, this regulation requires fatigue and damage tolerance that you will avoid catastrophic failure due to fatigue, manufacturing defects, and accidental damage. Here too, industry standards can be used to help ensure that you do not have these events happening. You don't want catastrophic failure. You don't want manufacturing defects. You don't want fatigue and corrosion. And how do you prevent that? And that really begins with solid material and processes. And but even other certifications can be part of industry standards. Another area in the engine world, which is heavily laden with additive manufacturing parts, you have to have engineering, manufacturing, and service management plans that work together to ensure that you do not have service failures of, well, any part. But what do we do when you have to develop an engineering plan, a manufacturing plan, and a service management plan for additive manufacturing, especially when it's new? You have no service data to rely on. You're creating it from scratch. And that's where another industry standard has been particularly useful. And in this case, it was an AIA Additive Working Group report on recommended guidance for certification of AM components. And this came out in 2019, I think it might have been, 2020. And it gives best practices in the areas of M&P development, part qualification, and development of material allowables and design values, all of which you have to do to certify a part on an airplane. And, we're very happy that AIA put this report together. And it's something that if you follow, you can expect that it's something the FAA would be satisfied with for many applications. AIA is the one that came up, or they documented the process of doing this development, supply chain qualification, properties, part design qualification, and then quality control. It's very similar to what we've done forever in aviation, but just making sure now that it's well documented how these philosophies are applied in additive manufacturing world. Why are standards so important? Because the FAA is not publishing much anymore, is the truth. Right now, we have a policy from it's government-wide policy that we must use voluntary consensus standards in lieu of government unique standards in our regulatory activities. And we have to report to NIST and the OMB when we elect to use or develop our own unique standard in lieu of a industry standard. In addition, we have the FAA Reauthorization Act that says our guidance and policies are supposed to be based. And performance-based is great in so many applications, but sometimes you really need the details. How many tests do I have to perform of what materials in what orientation with what build process, what is the minimal information for different documents? Those details really become important at some point. And if it's not in anything that the FAA publishes, that's where we need the industry standards. Useful places for industry standards, material and process specifications are the most obvious one, but qualification processes for facilities, equipment, and personnel, repair, huge area for additive. But best practices is something we also like to see. What are lessons learned in design and structural substantiation? What worked, what didn't work? And then, of course, material databases are going to be important in the additive world. The FAA is actively involved with the AIA, AM working group that I already mentioned. We too partake in America Makes, the American Welding Society S20 Committee, ASTM F42. We support many of the working groups. The ASTM COE, we're on the advisory board, R&D team, the Engineering Workforce Development team. We are part of the CMH17 AM coordination group, as well as MMPDS, their volume 2 activities. We join a lot of our research with CART and then SAE, Additive Manufacturing Committees. We support all of those as well. We also have a fairly large research portfolio of what the FAA sponsors in both polymer and metal AM. To point out again, MMPDS is creating volume 2 for process-intensive materials, so that'll be databases, statistics, methods, and best practices. CMH17, which is the Composite Material Handbook, they actually have a new volume to provide non-metallic additive manufacturing material data, describe how to generate the data and how to use it with proven best practices. ASTM F42, the ASTM Center of Excellence, SAE committees, and then we have several projects where we are creating databases, including standards for material and process specifications, and as I said, best practices. So in summary, we really plan to leverage our existing regulations and lessons learned with other advanced materials to the greatest extent practical. Industry standards organizations are encouraged to develop standards that support regulatory compliance. We believe that it promotes safety, and we hope that they focus on means of compliance to existing regulation. M&P controls are definitely the fundamental place to begin. And then we need to talk about, when we develop material and process controls, how are these scaled for the degree of rigor for a specific material and process control? For low criticality applications versus high criticality, we shouldn't always have to meet the same standard. Again, MMPDS and CMH17 are both developing new volumes, which will have significant information. And, one pitch, if we could get industry standards organizations to collaborate and coordinate to reduce overlap, that would be fantastic. But the most important thing is to make sure we don't have any inconsistencies in guidance. So. that's it for our presentation. Do we have a minute for slides? Or questions, I'm sorry, questions and answers.
We are just about out of time. Cindy and Kirstie, thank you so much. I think we will go ahead and ask one question, if you guys can answer quickly, that had a lot of votes. What is the best way to get involved in standards development if you don't have experience but still want to learn?
I could take this one. So at least to start, if you want to add anything at the end, Cindy, let me know. But the best way to get involved in standards development process is to join a technical committee. For example, F42 for additive manufacturing. That will allow you to be involved in the different processes and of the standards development process overall, and help you learn how things work. Do you have anything to add, Cindy?
No, I mean, any organization, they do not require experience. As you know, I'll speak a little bit for CMH 17. We're happy to have novice practitioners join handbook activities simply because as we write content, you can still review and read it. And if it doesn't make sense to you, there's something wrong with what's being written. So novice people can be great editors to make sure that the standards are going to work.
Yeah, absolutely.
Well, thank you so much again, ladies. That was a very informative presentation. I appreciate it. If you'd like to go ahead and turn off your cameras, we'll get our next presentation started. Our next presentation to close out this first block here in industry is a panel I'm very excited about, Entrepreneurship and Innovation with Desktop AM. I'm going to introduce the moderator, and then we will get her panelists on stage as well. I'd like to bring to the stage Meredith Hitner. Meredith is the Vice President of Strategic Partnerships for MatterHackers. And I also want to mention that during the COVID-19 crisis, Meredith developed and managed the Maker Response Hub, where she coordinated over 5,000 volunteers with 14,000 and up printers across the USA. And they ended up donating over 75,000 3D printed PPE to over 180 facilities in need. A lot of metrics there, but basically, Meredith, you're a rock star. Thank you for all you do. And I'm going to turn this panel over to you and bring your panelists on stage.
Thank you so much. Hello, everybody. So excited to be here. This is amazing so far. Thank you to the volunteers and the incredible men who have been working behind the scenes to make this event such a success. I see Meredith. It's like romper room. Meredith, and I see Danielle. Awesome. Okay, great. So my name is Matt, Vice President of Strategic Partnerships for MatterHackers. You can take down. We're just back for today. So I'm working with MatterHackers. For those of you who are unfamiliar, MatterHackers is the largest retailer of budget-friendly desktop 3D printers and materials, which is what we're going to be talking about today with my esteemed guests. Go to matterhackers.com. You'll see that we carry over 70 brands of desktop 3D printers, everything from little $300 kits to like up to $10,000-ish. Ultimakers, MakerBots, all the brands. We also carry over 2,000 types of different materials, including Quantum, which is our latest color-changing PLA. You may have seen it on Twitter lately. Specialty materials like stainless steel, which everybody's seen my little kitty ring that was printed on desktop printers. But today I'm really, really thrilled to introduce you to two entrepreneurs that I've had the honor of working with over the past few years. Start with Meredith Parnell. Meredith is an inspiring entrepreneur and mom who designs and 3D prints custom cookie cutters for her very successful Etsy shop, which I will put the link in the chat. It's called Sugar Dash Co. Last I checked, over 5,000 sales, 430 listings. It's probably more by now. She uses inexpensive 3D printers and lots of PLA to run her business from home, which would not have been possible without this technology. Welcome, Meredith. Thanks for coming. Good to see you. And then our second guest is teamconnection.org. Elle is an Indigenous robotics inventor, author, activist, an amazing advocate for youth. In 2019, she started her company, The STEAM Connection, a nonprofit that provides educational opportunities and super fun 3D printed robots to thousands of kids worldwide. Danielle has been recognized and profiled by People Magazine, L'Oreal, MIT, Verizon, various awards and fellowships. So excited she's here with us today. Welcome, Danielle. Okay, so let's start with Meredith. If you want to come off mute, tell us how you started with your business. Tell us your origin story. And just make sure you hit mute. You're still on mute, so just hit your little mic icon on the bottom there. It's red right now. When you click it, it'll be green. Up you go.
Okay, all good. My background is in video editing and photography, and that has always been my career path. I was in freelance, and then when the pandemic hit, I decided I needed to do something just in the meantime till gigs opened back up, because everything had been canceled, and I was at home. My daughter was at home full time. She's now 4. So I was making cookies one day with my mother-in-law in a class, and I wanted cookie cutters for them. I didn't want to hand cut them. And then I found out you could make your own cookie cutters. And when I did that, I found out I just needed a 3D printer. And all of a sudden, all of these women in the group were asking for cookie cutters and showing tubs and tubs of their cutters. And I realized there must be a market. So I went out and I told my husband, I'm starting a business. I'm just going to make cookie cutters. It sounds fun. And I took $300, bought my first printer. And I thought, if it doesn't work out, it's okay. I'm out $300 and I got a 3D printer. And that was best case scenario. And it took off. It just took a couple of months before cutters were flying out the door and just selling a whole bunch of them. And that's when I realized it was a full-time business. So now selling about 1,000 cookie cutters a week. We've just hit 15,000 sales. So, yeah.
Wow. That's amazing. From time to time, like, I check your sales just to see, and it's just like the sales is impressive, but the amount of files that you have available and the amount of different designs.
We have over 10,000 files now. Yeah.
Like, how
hard to keep it organized.
Yeah, like, how else is that possible for a person managing a business in their home without 3D printing? Like,
right. We started with one printer, and now we've got 12 that are running about 24/7.
Wow, that's awesome. Okay, so we're going to come back to you with more details. Danielle, let's hear a little bit about your history and your origin story.
First of all, I just want to say, like, Meredith is killing it. I love small businesses, especially Etsy ones. My mom has used Etsy for so long and is an artist. So I just think it's the most amazing thing ever. For me, I would have to scale back like 11 years now to when I got started. I was 10 years old and I was actually homeschooled. My little sister was interested in science and technology, but we didn't have any of those resources. A lot of the educational opportunities were way too expensive for us. And I'm like, there has to be something better out there. And there really was not. So I remember I was at Costco one day, which is like a store, and I saw these animal puppets, and I begged my mom to let me teach an animal science class at 10 years old for 25 kindergarten students over a semester. And it happened. I taught the kids. I learned a lot in the process, and it opened my eyes to education, as well as education in accessibility and steps that we can take to begin to fill those gaps. I'm Indigenous, and so I'm Ojibwe specifically, and there are a lot of resources that are not available to my community. So when I was in high school, I joined a robotics team, and I saw again and again how my community was being left out of those opportunities. The robots were like $500, and I'm like, kids need to access tech. This is important, especially in this day and age. Kids need to be able to know how to use computers to access the internet, things like that. And so I joined a robotics team, and I was met with a lot of hostility. It was a really difficult environment, and it pushed me to start my own nonprofit to create a safe environment for my students. And my 3D printer is what enabled me to do that and create robots that I give away to kids for free now.
Those robots are awesome, by the way. I will put some links in the chat for the work that you do. It's so interesting and heartbreaking to hear that you had such recent experiences of feeling like you weren't safe, or that you were excluded from programs that are meant for kids, robotics programs. You know, I hope that women, groups like Women in 3D Printing and groups like STEAM Connection can start to bridge those gaps and make it feel safer. I mean, if we're seeing that in education, Meredith, what was your experience like in entering the like the Etsy community as an entrepreneur, as a woman?
It was great. I didn't realize how big of a community it was. And the community has been very helpful. And I was really surprised by that. But I've made lots of friends through it, and it feels like it's been an easy transition.
Yeah, that's good to hear. It's from, you know, you and I did a panel last year, I think, about with Etsy shop owners using 3D printers, and it was you and I and two other gentlemen. But at the same time, I feel like, I don't know, Danielle, you were mentioning as well, your mom does a lot of business on Etsy, and it does seem like it's a little bit more friendly for women, for sure. But we, you know, you see that in any businesses, especially in additive manufacturing. Some people have really great experiences. Some people have, you know, a little bit more friction. Danielle, can you tell us a little bit more about the robots, the gap that you saw with the robots that were available, and kind of how you use 3D printing to bridge that gap and make a more affordable option?
Yes, of course. Talking about robots is my favorite thing. I love it. It's so exciting. I make robots every day, and I think it's the coolest job in the world. A few years ago, I was helping start robotics teams, and I noticed that a lot of the students weren't able to afford the kit. It was about $500. I was looking online for affordable robotics kits because I think that robots are such perfect ways to teach kids about engineering, and it just didn't exist an affordable one. So I decided to make my own when I was 18. And this is the first one that I made, named Ecker, or Every Kid Gets a Robot. And it's a robot that costs less than $20 and goes to kids for free. And it's 3D printed. Actually, when I first invented this, I didn't even have a 3D printer. I had someone else print it for me, and this is what the first one looked like. It's a little bit rough. I soldered out parts of it to make the components fit, but this was the very first kind of model that I had. And we've grown from there, have sent out thousands and thousands of robots. And it's such a huge blessing. But we print these, and we also have volunteers print them for the kids. And then my newest robot is something that I really want to show off. And its name is Scobots. And it's an indigenous language learning robot that costs less than $100 to make. And look how cute it is. It's like a little droid. And it's actually wearable with a GoPro strap, and it sits on your shoulder. It just like clicks in. And it just sits like on your shoulder. And this is all 3D printed. As you can see, we match. And my robot speaks Ojibwe. And it helps kids learn our indigenous languages. It senses motion and then just starts speaking. And it's all 3D printed. This little shell right here, as you can see, it's all 3D printed. So my 3D printers have really enabled me to be able to reach kids, especially for free, and to bring volunteers and community members on board to teach kids about science and tech. And I think it's the most exciting thing ever.
That is awesome. I'm going to switch back to Meredith. I want to actually ask both of you about production, because there's a lot of conversation about desktop 3D printers being great for prototypes, for one-off jobs, but y'all are doing like massive production. So Meredith, talk us through kind of like when you had your one 3D printer and you realized, okay, this is a job, this is a full-time job in business. How did you then scale to meet demand?
It was when I couldn't keep up and I was starting to use my first printer 24/7, and I thought, I think I could get a little bit nicer printer now. I've got some cash built up from the sales. So I went and I bought my first printer from the store. I bought a Prusa. And when that came in, I realized I could double my production. And then it was, once again, every time I would go and I would hit that certain mark where I was running out of time to print it and it was becoming stressful, I knew that was a time to scale it again. And so I just did that every single time. Sometimes I would buy 2 printers at once.
And what are you using for management, like software or print management?
I'm using Octoprint, connected through Raspberry Pis.
Okay.
So that helps a lot.
Yeah. And then Danielle, tell me about, I think this is kind of a challenge that you're starting to bump up against. You have a very different kind of strategy for production though.
Yeah, so my strategy right now, because we're not able to meet demand, since we're a nonprofit, we make as many robots as we can make and we send them out for free. We get thousands and thousands of robot requests like a week, and we cannot meet that demand at all. So what we did is created a 3D printing portal where volunteers could come in and print parts for us and send them to us. And that way we're able to get those robots out to the kids. And I'm not running my little printer 24/7. And that has been a huge blessing. So many people have rallied around sending robots to the kids, and it helps us keep those numbers up, which is great. But yeah, we're buying more printers soon. So we're starting a little print farm, and I'm so excited. So yeah.
Yeah, it's great. It's been so exciting watching this process, and then being able to help out wherever we can. What kind of materials are you using for your robots, Danielle?
I use PLA.
Okay. And Meredith, how about you?
Yeah, it's all PLA.
All PLA. Why is PLA so attractive?
For me, PLA is attractive because it's low temperature. It's really easy. I'm not having to build enclosures around each printer. Also, PLA is a little bit more food safe. They're big, so you don't have to worry about the bacteria, but when it comes to chemicals, it's a little easier for that.
For me, I started printing on with ABS, and I noticed a problem of the kids snapping a lot of the components, and PLA has a little bit more flex in it. And so those prints were a lot more durable for the kids, and we had a lot less breaking robots, which was a good thing.
Meredith, what was one of the pleasant surprises that you found when starting a business with 3D printers, desktop 3D printers?
That I think one of the pleasant surprises was that I could run it all from home. I could run it from my laptop. I didn't have to put a card into each and every printer, and I could print on demand. If I wanted to go on vacation for a week, my printers could rest, or I could have someone come over. I've trained my dad since then to come over and run my printers and shipping, so I can still go out of town. So that has all been a pleasant surprise with it. That, and I can still have fun projects on the side. So I'm actually working on a little robot myself. But,
oh yeah,
yeah, first one. So might come to you for help, Danielle.
I can't wait to see it.
Yeah.
Yeah. Is that going to be for another business?
No, that's just for fun.
Okay.
Yeah.
And then what has been an unexpected challenge, either with the 3D printers or just in starting your own Etsy shop?
I think just trying to grow slowly and not grow too fast so I can keep up with it. Because if I had this Black Friday the sale that I had this year, if that had hit the previous year, I think it would have tanked me. It would have been too big. So being able to just gradually grow has been so great, and just it has made it really manageable. And I think the space that it takes up in my house has been a bit of a struggle, keeping all of the boxes and the packaging supplies that has taken over my car spot in the garage. So we are actually about to move this all to a nice size workshop where everything is in one spot. And I think that'll be really helpful. But those have been some of the challenges, that storing the PLA, ordering it, and a little bit during the beginning of the pandemic, it was hard to get some PLA. PLA colors were running out. I know a lot of things, PLA that might have been coming from China was more difficult to get. So there's still a little bit of that worry. Is that going to happen again? Is it a steady flow now? Do I need to stock up? So we try to keep a little extra on hand too. We're doing about 50 rolls a month, I think is what we're at. So we try to keep about 1 month extra on hand.
Yeah, a great point. And I think is for American production for materials, that at least for MatterHackers, like that's what we're seeing. We're trying to, so hopefully we can manage some of those struggles.
Yes.
Because the world, who knows on a day-to-day basis what's going to be happening. And Danielle, what kind of challenges have you been seeing with growing your business with 3D printing?
I would have to say that a lot of my struggles are very similar to Meredith's. I'm actually speaking with you right now from our headquarters, which is a small little conference room. We're very thankful to have it, but we are very quickly outgrowing it. So we're actually looking for a new space to expand into, and also get some industrial equipment like a wave soldering machine, some industrial 3D printers, a mill, stuff like that, because we do a lot more than just 3D printing. We do a lot of roboting in general. And I'm like, I want a saw. Can we please get a saw? So we are working on expanding into that and kind of learning like how, like coming into a schedule, I think, like who can come in and change the 3D prints and run that and run, shipping and things. Because a lot of time I'm doing it myself, and we have a very large team, but we're from all around the United States. So we're all youth led. Almost everyone is a student. So that has its own unique challenges of just, there aren't a lot of people physically here to help with that expansion. So yeah, that's kind of the stuff we're working on, like hiring, expansion, all that fun HR stuff.
It's almost like running a real business.
Yeah, just a little bit.
Yep. And what about unexpected pleasant surprises, Danielle, in your journey with this?
I would have to say just the support that I've received from community members, especially those who are makers and who print things for us and who support us, who ship us parts all the time, just unexpectedly. I'm so thankful for that. And it's so nice to be able to open my door one day and see a bunch of parts that I'm able to the next day ship out to Indigenous educators and students. It's always a surprise to me how much people care about educating kids about robotics and about STEM. I just think it's amazing. And to see how much people have rallied around our language learning robots especially has been really cool. And they'll have their own little table at 3D Experience World in a couple weeks in Atlanta. So they're the makes the SolidWorks software, which is what we designed all of our robots on. So I'm really excited about that, and I'm just excited to be able to get the robot out to more kids.
So great. Both of you mentioned shipping struggles, which I feel ya. When people think about it's so great that we now have these inexpensive machines and materials that you can start your own business, but there's those stumbling blocks that you don't always think about, like shipping, like having a room for your shipping materials and all of that. Meredith, what's I guess just some overall advice that you would give? What do you wish somebody told you about starting a business with 3D printers?
I wish I would have known that the 3D printing is such a small part of it. And there's the whole scale of the rest of the business that goes along with it. From designing to the HR, you've got packaging. Now I've got cousins that are helping, my parents are helping, my husband helps me. There are just so many different areas that I had no clue all would fit in to create this business. Supplies and managing supplies, customer service. If there's ever an issue, if somebody's package doesn't arrive, things like that. So there's a lot. Custom designs, photography, videos, video editing comes back into play. So there are so many areas to think about.
Yeah, all of the marketing and everything that you need to do.
Yes.
Danielle, how about you? What do you wish somebody had told you for this journey?
To surround myself with people who uplift me no matter what. when I was starting out, I didn't really have a sense of like a 3D printing community or a women in STEM community or a women in small business community. And it took me a very long time to be able to kind of stand on my own feet and to feel confident in these spaces, especially engineering spaces. I really wish someone had just kind of slapped me in the face and said, go get a mentor right now, you know? And I was able to find mentors by just DMing people and by pestering my friends, like, hey, help me out, please help me. I want to learn. And just asking those questions and reaching out to people has helped me so much. It helped me build that support network. It helped me create a space where I was welcome. And that's what I suggest for everyone, no matter what industry you're in, no matter what you're doing, find people who support you and uplift you no matter what.
Yeah, that community
Awesome.
support for me has been so important too. I mean, during our Black Friday sales, we had a friend actually lend us his Pulse printer so we could help keep up. And it's just, it's hard to imagine it without that community support.
Yeah, people say this this industry of additive manufacturing and 3D printing is all about the technology, and I often say it's not, man. It's about the people. It really is. Mentorship is a great topic. Meredith, have you had any experience with mentorship, either purposefully or just in your journey?
I haven't, not with 3D printing. Everything for me has been self-taught and researched. I would like to, but at the same time, a lot of people I would ask questions to, I feel like, are my competition, and I don't want to do any damage there. So I have had small chats with a few people that also do cookie cutters on Etsy, but it's very minimal. So my community is just kind of watching cookiers, the people who make the cookies, and working with them. That has been more of my support group than the 3D printing side, but I'd like to look for it.
Yeah, interesting. We do have a couple of questions in the Q&A. Okay, so you kind of touched on this, but as far as 3D printing things that interact with food, any safety concerns, food safe plastic or bacteria growth getting in between the layers, how do you address that with your shop?
So the idea with the PLA, it can't be put in the dishwasher. So you do have the risk of bacteria growing in between those layers. But the idea is that you're not using it on raw food. You're not going to eat the raw food. You will stick it in the oven. That would kill the bacteria. So that is the idea there.
Yeah. Yeah, often with MatterHackers, we get a lot of those kinds of questions. And like, while there is food safe material,
Exactly.
Again, the process, you have the little layers. So, you know, they're sort of disposable, but you just got to be really, really careful. But, you know, something custom like a cookie cutter. Can you show us actually that we haven't seen show and tell from you yet?
Show
Can
us.
you show us a couple of designs?
I can.
I love that they're monochromatic.
This is kind of a multi-cutter, and what that looks like. These are usually big sellers come St. Patrick's Day. They're little St. Patrick's kind of figures.
They're so cute.
Rainbows. So that's kind of what that looks like, and we have like a double edge to help make it sharp and sturdy, and they're really strong, so they're not flimsy. You're not going to break it. So that's kind of what that looks like.
Yeah, people don't really understand how strong PLA is.
Right. Yeah, it's really strong.
It's a lot stronger than it gets credit for.
Yeah, for Valentine's Day, this has been huge. It's just a donut that cuts a heart out.
That's great.
Yeah, but yeah, super strong, super sturdy. It will melt in the dishwasher. It'll warp, and it happens. We try to tell people not to, but you know, it happens.
Yeah. Let's see. What tips? This is a little vague, but I'm going to ask it and just kind of leave it an open question. What tips would you give to with 3D? You all interpret that any way you like. Danielle, you want to take a stab?
Sure. I'm not quite sure if it's someone starting 3D printing for the first time or maybe branching out, trying new materials, trying a new printer or something like that. But I always suggest to read up on something first and to ask a lot of questions before you get started and potentially waste some money or materials. For me, part of the learning process is just, as I said before, like pestering people in the DM, just asking questions that I don't know. And that has really given me the courage to be able to expand into new materials, to new inventions, to new ideas. So I recommend like just asking people about it first, and it can really help you like find out a lot that you wouldn't know, especially like which machine should I be using, which filament should I be using, what should I print, where should I get these files from, what software should I be using. So yeah, I recommend ask a lot of questions first and then start.
For me, I would say plan to fail. Expect to have some failed prints and just figure it out that way. For me, that's what a lot of it was trial and error.
Same here.
Yep.
But as I said, like before, my first prints were a bit rough, and you just keep learning and perfecting from there.
My first cookie cutters were flimsy and were easy to break. So I'm surprised I got so many good reviews in the beginning, but yeah, you learn.
Yeah, you always, I mean, that's what 3D printing is really made for, right? Is that iteration, and I almost said innovation, but like also innovation. So when you want to try something new, even for your own established business, with 3D printing, you can do that because you're just designing a new file. Which brings me to the next question here. This one is from Meredith, but we can, Danielle, you can chime in as well. What software do you use to design your cookie cutters? And can you tell us a little bit about the process? Because you do a ton of different files and designs, but how do you decide what designs you're going to offer?
Okay, so for me, the process is getting a design. Let's say I'm just going to make a heart, or let's say I want to make this cutter. I would first sketch it up. Usually I use Illustrator. I use a lot of the Adobe software products. And then from Illustrator, I would take it into a program like Fusion and build my cutter there. Then I use this little guy here. It's called a jelly comb, and it's got, it's programmed. So the idea is I can use this to make multiple sizes at once because each cutter is available usually in about 8 sizes. So I can press one button and it will go ahead and make a file for each size automatically. And then it will go and rename them for me. So I'm not sitting there having to rename every single one based on the size. And then all I have to do is move it to the correct folder. So that's a lifesaver. We also use it for printing our slips and